Okay, Bismillah. Assalamualaikum warahmatullahi wabarakatuh. And this is still in chapter 3, right? We are still in chapter 3. This is chapter 3.4, where in the previous class or recording, we have covered the early part of chapter 3, which deal with equilibrium of a particle for two-dimensional problem. Right now, we'll go into the three-dimensional problem, and the concept is all the same. It's just that we transition from two-dimensional problem into three-dimensional problem, inshallah. Okay, so let's get straight to it, inshallah. Bismillah. Going through the slide, you can see the slide 3.4 and the application, etc. Obviously, many issues, many problems in the real life is in three-dimensional. So that's why we have to learn about three-dimensional. And just a reminder, just like in chapter 2, we have covered 2D and then 3D, where some of the trigonometry issues is becoming one of the challenges for some of you. Make sure you have resolved that one. And in this one, we will make use of all those things that you have learned already in chapter 2, right? The projection angle, alpha, beta, gamma, using position vector, etc., to get the vector for each forces, right? And basically the concept, if you go to the slide, the concept is exactly the same, right? Meaning that in equilibrium, summation of forces to be 0. Summation of force, if you write summation of force in terms of vector equal to 0, right? So we'll have summation of fx equal to 0, summation of fy equal to 0, summation of fz, right? So this is the new component here. In 2D we only have 2 equations, in 3D we have 3 equations, right? So that's the only thing different. Otherwise, the concept is exactly the same, right? Of course, the calculation might be longer because in 2D we have only 2 equations and we can have simultaneous equation for 2 unknown. For 3D, you can have simultaneous equation for 3 unknown. So that's the difference. Alright, so yeah. So that's why if you go to the slide, it straight away go to the example, and let's go to it, right? Now, so if you look at the example, so it will be quite challenging for me to draw this one because it 3D is, but let's try. So we'll have x, y, z. Okay, so I'll have this axis x, y, and z. So we have 5 forces there. So F1 is, so we'll have, how to draw this one. So we'll have something like this. Okay, so this is F1. Okay, basically the particle is already there, right? So if you see this example, example number 1, it is actually already a free body diagram. It's already a particle and all forces, right? This is not normally in midterm, it's still possible to have this kind of problem, but in the final you will not get problem where the free body diagram is already drawn for you, right? This is just to test you on vector, Cartesian vector and equation of equilibrium. Okay, anyway, so this is F1 equal to 300. F1 equal to 300 Newton, and the angle is given 3, 4. Alright, so that's 3, 4, 5, and then we have F2 straight away there. So F2 is here. Okay, maybe I should have the axis testing, right? F2 is 600 Newton. For our F3, F3 goes down 900 Newton. F4 is, okay, F4 is somewhat here. So F4 is somewhere there. It's still under inside. Okay, 200 Newton. where this is 3 meter, this is 4 meter, this is 6 meter. Right? And then F5. So F5 here, F5 we do not know anything about it. We do not know the magnitude, we do not also know the direction. It can be back there or front here, we don't know, right? So in this example, we have 4 forces. All the 4 forces are known, both magnitude and also the direction, and we need to find F5. The question is, find the force F5 to required to keep particle O in equilibrium. So meaning that what this need to be for this to be in equilibrium, right? So make sure you understand the question properly, right? It is different than chapter 2. If we have, for example, in chapter 2, the question might be with F1, 2, 3, 4, find the resultant. Then F5 becomes F1 plus F2 plus F3 plus F4, right? But in this case, it's not. It is different. It's that we have 5 forces and it is in equilibrium, meaning that when you add all 5 forces, it should be equal to 0, right? So make sure you are able to understand equilibrium and resultant force. That's 2 different topics. Alright. So from the idea is quite straightforward. Summation of all forces should be equal to 0, right? So as long as you can express F1, 2, 3, 4, 5 into Cartesian vector form, then you can just add and it should be 0, right? So let's try. So what to do? What do you need to do? Right, so let's do one by one. So summation F1 in terms of Cartesian vector form. How to express this one? F1. Right. So hopefully you can understand from the diagram that when you have line like this, meaning this is the line parallel to Z, this is the line parallel to Y, meaning it's on YZ plane. When it's on YZ plane, obviously X equal to 0, right? X component, so 0I, and then plus Y component is this one, right? So plus 300 4/5 J plus 300 3/5 K. Is it still in the frame? Yes. Alright. So that's from here, right? So no X component, Y component is 4/5, Z component is 3/5, right? So we have learned the projection before, right? F2 is straight away on the on the x-axis negative, so F2 is minus 600 I plus 0J plus 0K, right? And then F3 so it's straight away down, so 0R plus 0J minus 900K. Alright, F4. How do you determine F4? Right, when you have this information. So actually there are 2 ways. One is if you want to use 2 triangles, meaning you have to make one triangle here, another triangle there. One is if you want to use position vector, unit vector. Right? You can try both ways, it should give you the same answer. Right? So let's say if you want to use position vector. So if you use position vector for F4, basically the 2 important point is, let's see here 0, 0, 0. This one is 3 minus 4, 6, right? The coordinate, and it is like that. So you can calculate R is 3I minus 4J plus 6K. R magnitude is square root of 3 square plus 4 square plus 6 square equal to something, right? Let me check the number. Okay, so you can calculate this one because in this case the number will have some decimal point or something, right? If you calculate until the end. So unit vector is simply just the this vector divided by this magnitude, and then f is simply 200 times this unit vector, right? So I'm not writing in detail that one because you know this from chapter 2 already, right? How to deal with position vector, magnitude, unit vector, and force, right? That is if you use that method, right? If you use two triangle, it should give you the same answer, right? You can try. So then F4 you will get that value, right? You have something I plus something J plus something K, right? So, but in this case, you will know that it's actually negative J, right? So this one will be negative, right? Meaning whenever you get the value, because this is negative, obviously, and down here you'll get negative also, right? So you can express that. You have learned that already. So what to do? F5 is how to express F5. Now, because we do not know the whatever the magnitude and also the component, the direction, we can just make three unknown, right? So for example, f5x I plus f5y j plus f5z k, right? So you will end up with 1, 2, 3 unknown, right? And what equation do you have? So basically, we know that summation of f equal to 0, or basically f1 plus f2 plus ft plus f4 plus f5 equal to 0, right? So, or if we take the component, let's say summation of fx equal to 0, meaning you add all of this should be equal to 0, right? That's basically what it means. Now, that is the reason, if you notice that I write all of this 0, 0, 0, 0, right? Actually, if you just want to write, for example, f3 equal to minus 900k, that is correct. f2 equal to minus 600i, that's correct. But it will be easier in the exam if you write like that, so that when you want to add, etc., it is clear which you are adding x component, y component, z component, right? Easier for you not to make mistake and easier for the examiner to follow, right? If you write this minus 900k here, sometimes you can make mistake in the exam, right? So my suggestion, make a habit of having a structured way to write so that it's easy to follow and easy to check, right? So in this case, what you'll have is basically 0 minus 600, minus 600 there, plus 0 plus whatever value here, and then plus f5x equal to 0, and straight away you can calculate f5x equal to whatever answer there, right? Because this one, the value you already got right here. It's just I'm writing here because I'm not spending my time to actually show the value, but you have it in the slide and you can use your calculator anyway, right? So you get the value. Similarly here, summation of fy equal to 0, meaning that you add all of this should be equal to 0, right? So if you add, then you have this one. So 300, 4 over 5, plus 0, minus some value here, plus f5y equal to 0, then f5y, you can get the answer straight away also, right? So similarly, summation of fz equal to 0, then you add all of those together, so you have 300, 3 over 5, minus 900, plus whatever value here, plus f5z should be equal to 0. And then f5z equal to something based on your calculation, right? So in terms of the calculation, it is straightforward like that, right? So you'll have x component, y component, z component of f5. Now, what is the question just now? Okay, if you see the slide, the question is written like this: find f5. Right, in the vector form, right? Obviously, it doesn't have the arrow, but it does have the bold letter, right? F5 bold, meaning the vector, right? So it is basically find the vector. So if that is the case, you stop here is not yet the final answer. The final answer should be, okay, then f5 vector is this component here I plus this component here J plus that component there K Newton, for example, right? So that's how you solve and you get the final answer. So I think I mentioned before, but maybe it's good to remind you now. Make sure from the beginning you write something like the final answer should be in what format, so that when you calculate, sometimes you forget that this is not yet the final answer, right? So make sure when you start to write, what is the end calculation should be clear. Okay, final answer should be something like this, right? So this is what I want, so it should be in that format, right? So when you get here, just look, oh, okay, it's not yet finished, I have another one step, for example, right? Okay, so that's the example number 1. So you get your answer there. Of course, for the actual number, you can see the slide, inshallah, right? So I'm just showing you step by step of how to understand what's going on. Alright, so again, from the very beginning, the concept is clear, it should be clear. When the question is about equilibrium, you should know that equilibrium means summation of all forces equal to 0. So as long as I can express all of these forces into Cartesian vector form, I add all together, it should be equal to 0. So that's number 1, you should be able to visualize. Second, how to get each of these forces into Cartesian vector form, right? We have learned that in chapter 2. Now we are going to just apply. So make sure you have revised enough in chapter 2 on different projection angle, using position vector, etc. Whatever the case that you need to do, you have already covered and you understand that already, so that you can do this straight away, right? Of course, if you make any mistake there, or here, or anywhere there, the calculation will be affected. Again, I keep reminding, but this is super important. Make sure your chapter 2 is solid, right? Because you will keep using that one throughout the chapter, right? And then you just add summation of force equal to 0, then just mathematical calculation. Alright, so that's basically example number 1. Let's go for example number 2. So if you can see the slide, example number 2 is a bit different in that it doesn't actually give you the free body diagram yet. There's some 3 ropes, right? 3 cables or 3 cords, it says there. So you have to draw the free body diagram in the answer paper for your mark, right? For this one, it's already in free body diagram, so it doesn't matter. Alright, so basically we have, okay, so for the original question, please refer to the slide. I will just straight away draw the free body diagram, right? Alright, so there's 3 cords given there, like 3 ropes, and then it says 600 Newton load is supported by 3 cords. So meaning the 600 Newton, you can see the downwards force there, right? So find the tension in cords AB, AC, and AD, right? So if you draw the free body diagram, so this is X, Y, and Z, right? And where is the body? The body is at the origin. Alright, so we have 600 Newton down, 600 Newton down, alright. We have FAB, right, where the angle is given like, okay, so it's on this plane, right, it's on the XY plane, with the angle of 30 degrees. So this is FEB, let's call it FEB. Again, in your free body diagram, you have to label it properly, right? So let's label this FEB. And then FAC is on this axis here. FAC. FAD is basically you have something like that. Up. So there you go. FAD. Now in your free body diagram, you can draw the lines like this, the dotted line, right? To make the direction clear, right? But make sure you do it, the way you draw is not mistakenly as axis or as force, etc. Right? So make sure it's clear. Alright, and it's basically 1, 2, 2, right? So this is 1, this is 2, is it meter? This is 2 meter. Alright, so what to do? That will be your free body diagram, meaning that each forces have the label, either the magnitude or the unknown label, and then all the direction is clear. This direction is on this axis, is clear. This direction is on that axis, is clear. This one have this to show that it's on the XY plane, and then with the angle, this one to show where is it projected to, right? So the concept is simple, right? Summation of all forces should be equal to 0. So if we can express every of these force into Cartesian vector form, we can add them together, it should be equal to 0, right? And then we can solve for this unknown. Right, so what is FAB? Alright, so what is the x component? X component is here, so FAB, because that's the magnitude, sine 30, right? Sine 30 I. This one here, right? And then y component is plus FAB cos 30 J, right? And then it doesn't have any z component, so plus 0k, right? So that's for this one, right? Cos and sine. What about FAC? FAC, x component is negative FAC, right? So negative FACI. Y component no, Z component no, right? So plus 0J plus 0K, right? FAD. Right, so for FAD, again it depends on whether you want to use the two triangle or you want to use position vector. So I will use position vector here, right? So if you use, okay, let me just draw here, right? For AD, right? This point A, this is point D. So this is 0, 0, 0. This point D is 1, negative 2, 2, 1, negative 2, 2. 1, negative 2, 2, right? So RAD, the vector is 1i minus 2j minus 2k, plus 2k, right? 1 minus 0, 1i, 2 minus 2 minus 0, negative 2, 2 minus 0, plus 2, right? So RAD, the magnitude is square root of 1 square plus 2 square plus 2 square, which is 4, 8, 9. Square root becomes 3, right, I believe. So unit vector UAD becomes 1 over 3i minus 2 over 3j plus 2 over 3k, right? Vector R divided by magnitude R. So FAD is just magnitude of FAD multiplied by this unit vector, right? So you get 1 over 3, so 1 over 3 f e d I. So you have minus 2 over 3 here, so minus 2 over 3 f e d j plus 2 over 3 there, so plus 2 over 3 f e d k. Right. What are the other force? We have this one, 600 Newton, right? So I'm not sure to label what name to give it, so I'll just use F 600 for example, the vector. So this is straight down, meaning that 0I plus 0J minus 600 K Newton, right? Now, after you have already listed the 4 forces, right? Double check. How many forces you have? 1, 2, 3, 4. Alright. So double check always, because sometimes when you write this one, you forget to consider this 600, right? Because you don't have the name for it. Sometimes you forget, right? So make sure you double check. Now, what you have here is 4 equation, right? But okay, this is expression, not yet equation. So for 3D, you have equation, which is summation of fx, summation of fy, summation of fz equal to 0. How many unknown do you have? So basically you have fab, the same one here, fac, fad. This is the same unknown, right? So you have 3 equations, 3 unknown, you can solve. Now if you do summation of fx equal to 0, meaning you add all these components. If you do summation of fy equal to 0, you add all of these components. If you do summation of fz equal to 0, you do all of these components. Now, again, sometimes which equation you decide to start with can affect whether it is straightforward or difficult, right? So in this case, which one should you use first? Like, just take a look. Sometimes you have to use simultaneous equation, right? So life is hard, what to do? But sometimes there's easier solution, right? For example, if you use summation of fx equal to 0, how many unknown? That's the question. How many unknown in that equation? We have 1, 2, 3. Alright? If you do summation of fy equal to 0, how many unknown do you have? 1 and 2. Alright? If you do summation of fz equal to 0, how many unknown do you have? Only 1. So it's best to start here. Right? That's how you decipher. Before you write anything, just see what is the best way to start and start there. Right? So, summation of fz equal to 0, basically you add all this. So 0 plus 2 over 3 fed minus 600 equal to 0. Right? So you can solve straight away, right? So fed equal to 600 3 over 2, right? So 900, I believe, right? Okay. So meaning that you already solved one of the unknown. Right? And then already know FAD, so FAD is known, FAD is known. So go here. How many unknown you have? 1. This is known, so you can solve here, right? Because only one unknown. So summation of alpha equals 0. So you have FAB cos 30 minus 2 over 3 times FAD, which is 900. Plus 0 equal to 0, so equal to 0. So can you solve this? It's straightforward, right? Is it too small? Hopefully you can still see. Right, so based on this, FAB is equal to, basically bring it there, 600 divided by cos 30. Right, you get some value there. And then you go for fx, right? So if I write it here, so FAB is already answered here, so whatever value there, blah blah blah, sin 30, and then minus FAC plus 1 over 3 FAD plus 1 over 3 FAD is already known, which is 900 plus 0 should equal to 0. So FAC, you can have answer that one there, right? So that's how you do it, right? So basically, the concept is not difficult. It's basically just summation of forces equal to 0. And in 3D, summation of fx equal to 0, summation of Fy equal to 0, summation of Fz equal to 0. As long as you can express every forces into Cartesian form, so you can add all the x1, y, and z, right? So it's straightforward. If you do everything in a formatted way like that, it will be straightforward, and the examiner can also follow straightforward, right? So again, how to get all of this? This is from chapter 2. Make sure you have done chapter 2 successfully and you understand everything, right? So if you just see the value, so you get the value there, right? So just see the slide for all the actual value. All right. So we have another example, which is in this slide. It says group problem solving, right? So for this one, it's quite interesting. So I'll erase this one first. I'm not sure. I have to be quick because the battery for the camera is dying. All right. I hope we can have the recording at the end. Otherwise, yeah. All right. So if you follow if you go to the, how to say this one, if you look at the slide, you can see the question where you have a plank of something, and then you have a plate, and then a motor, and then the 3 cable, right? So it says that 17,500 Newton motor and plate as shown are in equilibrium and supported by 3 cables, and D is 1.2, right? So there's a distance D there. You can just plot in D 1.2 there. So find the magnitude and tension of in each of the cable, right? So the question is, of course, right now we are in chapter 3. We know for sure that we are learning about equilibrium of a particle, right? But in the later stage, in the final, for example, you have to know that how to solve this, which chapter to use, right? So which is the particle that we consider, right? So there's 2 ways to solve this problem actually. Which body are you considering? Is it the motor, or is it the point A there, the ring there, right? So obviously we know for this chapter you can solve by considering the ring A, the point A, as the particle for the body of the that we're considering for the free body diagram, right? So in the end, basically you have point A, and then you have 3 forces going down, right? So basically you have 1 force here, 1 force here, 1 force here, and 1 force go up, right? And the force go up is already in the question, is already given the value, so 17500, so 17500 Newton there, right? And for this 3, you do not know the value, right? And that is what you want to find. So let's say this is FAB, FAC, and FAD, right? So how to solve this one, right? So what is the direction? So basically the point that we know is the coordinate of the end point, right? So basically this goes to point B, which have a certain coordinate. This goes to certain point C. This goes to a certain point D, right? Now, when I draw the free body diagram, I just use this dotted line just to show the direction, right? It is not part of the diagram itself, it's just to show the direction. Because if I draw the cable, then that's not a free body diagram, alright? If I draw anyway, so okay, let me start with point B. What is the coordinate there? Okay, point A, the coordinate is 0, 0, 3, right? So this one is 0, 0, 3. What is coordinate of point B? It is 1.2 minus 0.9, so 1.2 minus 0.90, right? So is it in the frame? Yeah. So make sure to take note of the negative side, right? So y coordinate there is negative, right? So 1.2 positive, right? What is point C? This point C is quite interesting because some students will get confused. How is this? Because D is 1.2. So if you understand that, point C is actually pushed from the side 1.2 meter, right? So if you go to calculate the coordinate, this will be 0, 0.9, 0, right? And then point D was the x direction is minus 1.2. It's minus 1.2. Okay, this is where sometimes some question can trick you. If you see point D, the distance 0.6 is given, right? But 0.6 is on that side. When you want to put the coordinate, it should be from the axis or the origin, right? So it should be 0.3, right? Look carefully. So the y coordinate is actually 0.3, right? Which is 0.9 minus 0.6, so 0.3. So 0.3, 0. Alright, so that are the coordinates, right? So once you have the coordinates, the rest should be simple, right? Because, not simple, simple to understand. The concept is straightforward. It's just some calculation steps that you have to do, right? So basically here, how many forces that you have? You have 4 forces, right? So basically, if you understand summation of all forces equal to 0, basically it's FEB plus FEC plus FED plus F17500 equal to 0, right? In terms of vector form, if you add everything, it should be equal to 0, right? So I don't know what's the level here, I'll just say force 17,500, right? Alright, so how to express each of these, FAB, FAC, FAD into Cartesian vector form? So we have to do one by one, right? So for FAB, right? The 2 point, what is the 2 point that is important? Is point A and B, right? So A to B, right? And the coordinate is already there. So RAB should be, so coordinate B is this one, right? So 1.2 minus 0, so 1.2i, and then minus 0.9j, so 0 minus 3 is minus 3k, right? Minus 3k, right? So what is the magnitude? Basically square root of everything. I'm just showing you the step. You can try on your own with the actual number, right? And then unit vector of AB is basically RAB, the vector, divided by RAB magnitude. So basically they have something I plus something j plus something k, right? Well, not actually plus, because this one is minus, this one minus, so you know what to do, just follow from top. And then FAB is just the magnitude, we do not know, so FAB here, so FAB times something I plus something j plus something k here, right? And then you get in terms of, okay, this will be a bit complicated, I think, because it will be something like something FABI plus something FABJ plus something FABK. Oh. Right, so you have the multiplication there, which is whatever value that you get, right? So this is probably will give you some simultaneous equation. But anyway, so it goes next for FAC. So basically, from A to C, right? And we have the coordinate there, so I'll just use that. So 0 minus 0 is, so RAC, what is it? So 0i, and then plus 0.9j, and then minus 3k, right? That's the position vector. So the rest is just exactly the same stacks, right? Square root of everything. So UAC, RAC, UAC vector, and then FAC vector, right? So if you understand one step, it's basically just repetition using a new value for each corresponding one, right? So you repeat for F, A, D. So A, B. Now it's not compulsory to draw this one, but for me, I like to everything to be in paper so that it's easy for me to, one, avoid mistake, second, check, right? So I can easily see, oh, this minus this one, and normally I put the coordinate there so that it's easy to check. If it's somewhere here and then you have somewhere here. Right now I'm using a whiteboard, right? So I have a white space. But if you are writing in a paper, sometimes it's this page, that page, that page. So if I keep, when I mark, I have to keep flipping the page. That will be not the ideal case, right? You might make the examiner angry or something. So it's easier or more convenient is put it here systematically. Right? So here you have RAD equal to, so minus 1.2 is minus 0, minus 1.2i, 0.3 minus 0, plus 0.3j, 0 minus t, minus 3k. Then you repeat RAD, square root of everything, UAD, you can calculate here, FAD, you can calculate that. Right? Up till this point, you already have expressed FAB, FAC, FAD into Cartesian vector form. Remember, you have 4 here, right? That's where it's help if you write from the beginning, so that you don't forget. Because sometimes when you calculate here, you forget already you have another force here. But if you write here originally, then you realize, okay, 1, 2, 3, 4. So for F17500, that force is what? It goes up, right? So 0i plus 0j plus 17500k. So what to do? Right. So obviously, as I mentioned before, personally I do like to rewrite everything so that it's one line, right? So x component, y component, z component is easy to follow. Otherwise, if you have this separately and then you have to keep track, okay, x component here, x component here, x component there. So it's not wrong. It's just that mistakes tend to happen when it's not organized, right? So it's best if you have a habit to make everything organized, then it's easy to follow. When you want to check, it's also easy, right? Otherwise, when you want to check, where is this from? You have to look many places, and it's quite, when you are rushing in the exam, that's not quite ideal. Alright, so basically, you have how many unknown? 3 unknown, right? This is one unknown, FAB, FAC. Here you have another unknown, FAC, FAD. That's the third unknown, right? So you have summation of fx equal to 0, summation of fy equal to 0, summation of fz equal to 0. So basically in this question you will have 3 simultaneous equations, right? Because everything have, if you refer to the previous example that we have covered, when you have like 0 here, or something 0, 0, something like that, the calculation becomes easier because you have some 0 there, right? But when you have every number here, then the simultaneous equation may make it longer, right? And you have to show the simultaneous equation. And I think you have learned already how to solve simultaneous equation for 3 by 3, right? If in the exam you have 3 by 3, right? Sometimes you have to use the matrix or whatever. That's mathematics. Hopefully you have covered that and learned that and know how to apply for simultaneous equation, right? And then the slide already give you the answer. You can double check with that one, right? So please do try. And because there are several things where you might make a mistake. Sometimes the coordinate, sometimes you forget this force, etc., right? So only when you do exercises you will realize where you make a mistake and where you should emphasize in your study, so that you will not make the same mistake in the exam, right? That's very important. Alright, so okay, based on the slide, that's the end of the slide. So we have covered the full of chapter 3, alhamdulillah. Do try, because we only covered 2 examples, I think, for the 3D for chapter 3. And also in this slide, I think you do not have pulley, you do not have spring, etc. So you can try to see some example or problems with those elements, and try also for those example problems, right? And try whether you have any difficulty or not. And when we come to class, any problem we can discuss, inshallah. Wallahu alam. If you have anything also, you can write in the comment if you want to highlight certain things that is not clear, so that I can prepare for that, inshallah. Wallahu alam. So I think we will finish the recording here for chapter 3.4, inshallah. Wallahu alam. Subhanakallahumma bihamdik, asyhadu an la ilaha illa anta, astaghfiruka wa atubu ilaik. Wassalamualaikum warahmatullahi wabarakatuh.